Now, we've been using this word magnitude over and over and over again. What does it mean? Well, the magnitude of a vector is really the length of the vector. So when I'm referring to the magnitude of a vector, I'm saying how long is that vector. If it has a larger magnitude, if I'm going 25 miles per hour compared to 10 miles per hour, the 25 mile per hour vector would be 2.5 times as big or as long as the 10 mile per hour vector. So when we're in component form, we can say that the length is really just the distance from the origin. So the question now becomes, how do we evaluate? How do we calculate the magnitude of a vector? Well, assuming that it's in its component form and the sketch is in standard position, we can realize, well, if we have vector AB, that means we have vector starts at the origin, ends at the coordinate AB. Well, that really creates a right triangle where two sides of the triangle are A and B. And then the length of the vector is really represented by the hypotenuse of the vector. And we can figure out the hypotenuse using the handy-dandy Pythagorean theorem. So instead of saying a squared plus b squared equals vector squared, we can just go ahead and solve for the magnitude of the vector, which is the square root of a squared plus b squared. Now you'll notice the notation we use for magnitude is actually absolute value. It's important to remember the definition of absolute value because this is going to come up again in this chapter. It's going to come up several times. Absolute value does not mean make the number positive. The absolute value of -4 is not 4 because you just take the -4 and make it positive. Absolute value means how far is this number from 0. -4, the absolute value of -4 is 4 because -4 is 4 units from 0. Distance is a positive number. We describe distance with positive numbers. Absolute value is a distance. So when I say absolute value of a coordinate, well, a coordinate has two numbers. We're not just going to take each of those numbers and make them positive. We're going to figure out how far is that number from 0. Well, if I have a coordinate to figure out how far it is from 0, we can use the Pythagorean theorem. So that's why the absolute value of a coordinate is found using the Pythagorean theorem. So magnitude is just the Pythagorean theorem. Now, vectors have magnitude, they also have direction. We can figure out direction simply by using a little bit of right triangle trigonometry. Remember that direction can be described using just the angle theta, the angle that the vector makes with the x-axis. Alright, so keeping in mind A and B represent the x and y axes respectively, we can figure out theta. Easiest way would, since A and B is what we're given the opposite side, we're given the adjacent side. Let's just use inverse tangent. Remember, inverse trig functions are used to find angles. I could technically also use inverse sine or inverse cosine, but those would require use of the hypotenuse, which means I would have to figure out the hypotenuse before I could do it. So if you're just given A and B, might as well just use inverse tangent. Now it's important to remember though, it's only going to be this specific formula if you're in the first quadrant, because in the first quadrant we actually only get a reference angle. Every quadrant has their own little reference angle, the acute angle with respect to the x-axis. Sometimes we'll have to make adjustments based on the actual quadrant that the vector is located in. Now what I mean by that is, again, it's a reference angle. Theta sub r represents the reference angle. So if my component form tells me that yes, I am in the first quadrant, well, the inverse tangent of b over a is going to give me a positive angle that's less than 90 degrees in the first quadrant, and that's exactly what I wanted it to be, so the reference angle is the angle, no worries. It's when I'm in other quadrants that I really have to worry. So if I'm in the second quadrant, so my component form, my a value would be negative, my b value would be positive. Well, if I take the inverse tangent of b over negative a, so if I take the inverse tangent of a negative number, I'm going to get a negative answer as my result. If I take -3, -3, +3, so let's actually write that down. Let's say I'm at -3, +3. Inverse tangent would be 3 over -3. In other words, the inverse tangent would be -1. Well, when is tangent -1? Well, at -45 degrees. Alright, if you type this in your calculator, anytime you take an inverse tangent, you're only ever going to get answers in the first quadrant and the fourth quadrant. You're only going to get answers between negative 90 degrees and positive 90 degrees. So when you're in other quadrants, that's why we have to make these adjustments. So inverse tangent of negative 1 would be negative 45 degrees. Well, what that really means is I am at this reference angle would be 45 degrees. Negative just means you're either in the second or the fourth quadrant. You tell based on the component form whether in fact you're in the second or the fourth quadrant. So if I'm at negative 45, if the answer I get is negative 45 degrees, and I got to realize, well, negative 45 degrees is not in the fourth quadrant, the adjustment we can make is simply to add 180. If I were to take negative 45 degrees and add 180, I would get 130 as my answer. I'm sorry, 135 as my answer, which is, in fact, in the second quadrant. So it comes down to realizing that inverse tangent, if I were to say negative 45 degrees, that just means I'm going to measure backwards from 180, 45 degrees. If I'm in the third quadrant, I would measure forwards from 180. Well, good news is that in the third quadrant, tangent is always positive anyway. So if I were to do the same coordinate in the third quadrant, negative 3, the negatives would cancel out. I would be evaluating the inverse tangent of 3 over 3, inverse tangent of 1, which is 45 degrees. So it's just 180 plus 45. So if either I'm in the second quadrant or the third quadrant, the adjustment I have to make is add 180 degrees, because the inverse tangent isn't going to give me the correct answer. It's only going to give me the reference angle. And of course, if I'm in the fourth quadrant, once again, tangent is negative. I'm measuring from the x-axis. Remember that the x-axis in the fourth quadrant is represented by 360 degrees, so I would simply add 360 as my adjustment. So depending on which quadrant you're in, you have to make an adjustment. If you're in the first quadrant, no adjustment is necessary. Second or third quadrant, we add 180 to make our adjustment. Fourth quadrant, we add 360. Alright, let's look at an example. I want to find the component form, the magnitude, and the direction of the vector with the given initial and terminal points. So I'll give you a second to give this a try on your own. Pause the video and then play it when you're ready. Initial point 2, 5 and negative 3, 4. So I want to find the component form first just by doing head minus tail. And you should have ended up with negative 5, negative 1. Now to get the magnitude, remember magnitude is the Pythagorean theorem, so I will take the square root of a squared is 25, b squared is 1, add them together, I get root 26. So square root of 26 would be my magnitude. Now keep in mind, if you want to convert it to decimal, you can, but 5.099 is no more correct than root 26. It doesn't matter which answer you put down, they're both the same. And then direction angle, we'll use the inverse tangent of b over a, which is negative 1 over negative 5. Now notice, of course, the negatives aren't really necessary because they would cancel each other out, but I like to put them there anyway, just as an extra opportunity for me to double check which quadrant I'm in. If it's a double negative, that means I must be in the third quadrant. And if I'm in the third quadrant, I need to make an adjustment, and that adjustment is to add 180. If I'm in second or third quadrant, I got to add 180 to that answer in order to get an answer that makes sense. And that answer would be 191.309. Had I not made that adjustment, inverse tangent of 1/5 would have only given me 11-ish degrees, which makes no sense because I know from the component form that I'm in the third quadrant. So it's simply 11 degrees beyond 180. Alright. Do it again, one more try. Let's see if you get the same correct answer that I do. Alright, component form, negative 4, 3. Magnitude, 16 plus 9 is root 25, which is 5. Of course, you could have just recognized that this was a triple, 3, 4, 5, right triangle. Now, direction angle, inverse tangent of 3 over negative 4. We need to remember what quadrant we're in. We happen to be in the second quadrant. So our adjustment will be to add 180. 143.130 degrees. Alright, so just like we do in any math concept, we got to be able to work forwards and backwards. So let's give the component form of vector v if the magnitude of the vector is 5 and the angle is 87. Now, instead of me giving you the component and asking for magnitude and direction, now I'm giving you magnitude and direction and asking for the component. Well, we're still going to be using basic right triangle trigonometry. We know that the magnitude is 5, we know that the angle is 87, and we know that there's an invisible right triangle hanging out right in front of us. So component form is just what's the a value, what's the b value. And we can figure out the a and the b value using, again, right triangle trigonometry. I used tangent earlier to figure out the angle. To work backwards, we're actually going to use sine and cosine. Note that cosine of 87 would be a over 5 because it's adjacent over hypotenuse. Therefore, the a value would just be 5 times cosine of 87. So right there, I'm half done. There's half of my answer. To get the b value, I could just switch it up and change it to sine. It's still going to be magnitude times either sine or cosine of the angle. So that kind of gives us a little rule of thumb. When I'm looking for the component form, it's always just the magnitude times either cosine or sine of the direction angle. A is your x value, so I'll use cosine. B is your y value, so I'll use sine. So that gives us our component form of 5 cosine 87 times, or 5 cosine 87, 5 sine of 87, or if I were to convert to decimal, 0.262, 4.993. Now I can do the same thing for the second one. I'll give you an opportunity to try it on your own in case you haven't already. So I've got root 6 cosine of 150, root 6 sine of 150, which is really negative 2.121, 1.224. Alright, at this point, once we've gone forwards and backwards, I like to take a step back and summarize everything. This is a great opportunity for you to write down one small little place in your notes to keep all the handy-dandy formulas available to you, because these are really going to be the same formulas we're going to be using throughout this chapter. If I have a vector in component form, AB, that means I have a vector that ends at the coordinate AB, starting at the origin, which creates a little right triangle, side lengths of A and B. The magnitude can be described using the Pythagorean theorem, which is equivalent to the absolute value of that coordinate AB. Direction angle was inverse tangent, but remember that's a reference angle and may need adjustment based on the quadrant. And then to find the component form, if I'm going in the opposite direction, it's just the magnitude times cosine, the magnitude times sine. Now, as we progress further, you may also hear me refer to it as the rectangular form. Whether I call it component or rectangular, it's the same thing. Alright, why don't we give this one a try, a little bit more complex. Given vector v is at 5, 4, and vector w is at 2, negative 5, I want to find the vector u that is in the same direction as w with the magnitude of v. So in other words, I am looking for vector u. My final answer is going to be vector u. So if I want to know what vector u is, it would be really helpful to either know the initial and terminal points, or the new way I can do it is by knowing the magnitude and direction. Well, I didn't give you the magnitude and direction, but I did give you vectors v and w, and the magnitude is going to be the same as v's, and the direction is going to be the same as w. So what we can do to figure out vector u is start by figuring out what's the magnitude of v, then we can figure out what's the direction of w, and then we can use that magnitude and that direction to figure out our new vector u. So why don't you give it a try. So we'll start with the magnitude of v. We do that simply by using the Pythagorean theorem. 25 plus 16 gives me root 41 for my magnitude. To figure out direction, we'll use the inverse tangent. 2, negative 5 is in the fourth quadrant, so we need to make an adjustment of 360. And that's going to give me 291.801. Now, I know I'm going to be using this as this number to help me figure out vector u, so anytime you're going to be using an ugly decimal further on in the problem, don't round it off now. Use your calculator. Store it in the calculator. I'm just going to use A because why not? Start at the beginning. You can store it for anything you want. Let's go ahead and store that for A in the calculator. Then to write the component form, I'm going to use that magnitude and that angle to write vector u. So it would be root 41 cosine of A, root 41 sine of A, which is really 2.378 negative 5.945. And this makes perfect sense because I know the direction is the same as W, so if W is in the fourth quadrant, U better be in the same quadrant.